4.3, Algebra 2 from the Structures and Methods Dulciani edition. She's a pretty good math book writer. In this section, 4.3, we're going to learn how to multiply polynomials. So in this first example, you see a binomial times a binomial. Now it's a pretty sophisticated binomial because we have two variables, which is not very typical, times two variables, and we get a very interesting answer. So typically, something like this is a monomial times a monomial. We'll do something like this. We multiply their coefficients and then their variables. Then they amp it up a little bit and you get something like a monomial. Oh, let's not make it. A monomial times a binomial. You have two terms that this gets distributed to. So you have 2x times the 3y plus the 2x times the 4. So both of the terms inside get multiplied by the term outside. So 2x times 3x is 6xy. 2x times 4 is 8x. And then you can get even more sophisticated and you can do 3x times 6x squared minus 4x plus 2. So we have a monomial times a trinomial, three terms. And all you're doing is distributing to all three terms. More terms to distribute that 3x times 6x squared plus 3x times negative 4x plus 3x times 2. 18x to the third minus 12x squared plus 6x. Now, what they introduce here is you have two terms. So all you're doing, you have something like this. Now let's make that positive. So the way to look at this is you have a single term out here that you are going to distribute to each of the terms inside here. And then you have a second term that you are going to distribute to each of the terms inside there. It's what I call a double distribution. So you're distributing the x times the x plus the x times 4, and now you're distributing the 6 to the x and the 6 to the 4. So we see that we distribute this x to both of the terms inside, and then you're going to distribute this x, or this 6, to the two terms inside. And that gives us x squared plus 4x plus 6x plus 24. Your inside and outside are always going to be, well, not always, are going to be, oftentimes are going to be like terms, and we'll add those. And now we can't add any. Some people teach it as FOIL. You'll see FOIL, firsts, outer, first, outer, inner, last. So it's the firsts, the outers, the inners, and the lasts. Looks like a double distribution, no? It is. Your first is always going to be a product. Your last is always going to be a product. It's a product. And then this tends to be the sum of two products. And we saw that here. So this is a product, this is a product. So this was a product, this was a product, and we were able to add those. So that was the sum of two products. This is just a product, that's just a product. So I'm going to go fast in this. You should know this. You're going to distribute x to x and x to the 4. And then you're going to distribute the 2 to the x and the 2 to the 4. X squared plus 4x plus 2x plus 8. Your outside and inside are like terms, so you combine those, and that is your answer. You want to do these so much that you start seeing the solution. If you are given this, you know that the answer is x squared plus x minus 30. I can just look at it and tell you what the answer is. So you have to get to that level. In Algebra 2, you should already be there. You should already be there. There's no excuse to get to Algebra 2 and not know how to FOIL. Negative 5 times x, negative 5 times 6. X squared plus 6x minus 5x minus 30. These are like terms, x squared plus x minus 30. So I can see that super easy. Now we can do this. We go y times y is y squared. Y times negative 10 is negative 10y. Positive 6 times y is 6y. Positive 6 times negative 10 is negative 60. And then inside and outside are going to be like terms, and you get that. So that would be the next level that you go to. So you start showing all the steps, then you start seeing the distributions, and you can take out a step, and then you get really good. You can do x squared minus 15x plus 54. 56? 56, Mr. Mac. So you have x times x plus x times negative 7 minus 8 times x minus 8 times 7. X squared minus 7x minus 8x minus 56. X squared minus 15x minus 56. Here I am harping on plus negative times negative on accuracy, on speed, and I'm making silly mistakes. We will take it easy because we want to show the steps, and we want to be able to have students check their work compared to the work, the detailed answers. 3a squared minus 5a plus 6a minus 10. 3a squared plus a minus 10. Z times 6z plus z times 1 minus 4 times 6z minus 4 times 1. 6z squared plus z minus 24z minus 4. 6z squared minus 23z minus 4. Now the other reason is down the road, I'm going to give you this and I'm going to expect you to be able to factor it, to break it up from addition, subtraction to the product of two binomials. So we got to understand how these things are made. How did we get 6z? By multiplying that. How did we get negative 4? By multiplying that. How did we get the negative 23z? By these two. By combining these two. Well, how did we get those? From these two products. And why is this negative? Well, because we multiplied a negative times a positive. And we see a negative and a positive. So understanding this is really, really going to be key and contingent on being very good about factoring when we reverse distribution. Let's keep going. 2b times 3b plus 2b times 2 plus 1 times 3b plus 1 times 2. 6b squared plus 4b plus 3b plus 2, 6b squared plus 7b plus 2. It's well worth the time and effort to do this, to do these ad nauseum. I used that term in an email the other day. Plus 6 times 2m plus 6 times negative 3. 10m squared minus 15m plus 12m minus 18. And in the section before, section 4.3, we multiplied monomials times monomials. That's why it was important to know those. So when we see this, we can combine them pretty quickly and not think about what it is. So we get 10m squared minus 3m minus 18. R times 2r plus r times negative s plus 2s times 2r plus 2s times negative s. 2r squared minus rs. We're going to put our variables in alphabetical order. Plus 4rs minus 2s squared. These are like terms. 2r squared plus 3rs minus 2s squared. And that is standard form. We're going to go by the first variable of each term, r to the second, r to the first, and s. So r is going to always come before s, and r to the second is going to come before r to the first. So that's how we put things in standard form. This s squared is not going to come before any r's, because that's not before it in the alphabet. A lot of students mess that up. 4x times x plus 4x times negative 2y minus 3y times x minus 3y times negative 2y. 4x squared minus 8xy minus 3xy. Even though y was multiplied first, we would write it alphabetical order. Plus 6y squared. Like terms, 4x squared minus 11xy plus 6y squared. 7y times 2y plus 7y times 5z. That's this distribution. We're distributing the first term of the binomial. Now we're going to distribute the second term of the binomial. Plus z times 2y plus z times 5z. 14y squared plus 35yz plus 2yz plus 5z squared. Like terms, 14y squared plus 37yz plus 5z squared. We're going to distribute this to both of the terms. 3m times 2m plus 3m times 3n. And we're going to distribute out the negative 2n to both of those. Negative 2n times 2m minus 2n times 3n. 6m squared plus 9mn minus 4mn minus 6n squared. 6m squared plus 5mn minus 6n squared. That's a good one. All right. Now we have a binomial times a trinomial. So we're going to distribute that first term 3 times this time. And that second term is also going to get all 3 terms. So we will distribute a lot. A times each of these 3 terms. A times a squared plus a times 4a plus a times negative 1. And now we're going to distribute the 3 into each of those. So it's a positive 3 times a squared plus 3 times 4a plus 3 times negative 1. A to the third plus 4a squared minus a plus 3a squared plus 12a minus 3. No pairing, so a cubed. We have 4a squared and 3a squared, which is 7a squared. We have negative a and positive 12a, which is positive 11a. and then we have no pair for my constant. You do this, you take the time to write out all this. This one, there's no shortcuts. I don't know too many people that can look at it and tell me what the final answer is automatically. Maybe they can. There might be a way. There's some really good algorithms out there that help people. I'm going to take my time. 3t squared plus 4t minus 2t squared minus 6t minus 8. T cubed doesn't have a partner. That's plus t squared. That's minus 2t minus 8. 4x times 3x squared plus 4x times negative 2x plus 4x times negative 5 minus 2 times 3x squared minus 2 times negative 2x minus 2 times negative 5. Keeping track of those negatives, super important. 12x to the third minus 8x squared minus 20x minus 6x squared plus 4x plus 10. 12x to the third doesn't have a pair. 14x, this has that. That's minus 16x plus 10. 5y times 2y squared plus 5y times negative y plus 5y times 3 plus 1 times 2y squared plus 1 times negative y plus 1 times 3. 10y cubed minus 5y squared plus 15y plus 2y squared minus y plus 3. 10y cubed, it has a pair minus 3y squared. It has a pair plus 14y plus 3. All right, now we just have a trinomial into a binomial. So you just still, you're just distributing, and then you have a third term that you're distributing. So you're distributing 3 into 2 opposed to 2 into 3. So x squared to 2x, x squared to negative 1. Now my next term is negative 3x times 2x and negative 3x to negative 1. And now my third term in my first grouping is 5 times 2x plus 5 times negative 1. So 2x to the third minus x squared minus 6x squared plus 3x plus 10x. Ooh, yeah, that's fun. Plus 10x minus 5. So we have a 2x to the third. These are like terms. These are like terms, so we notice that they actually saddled up nicely. My arm is dead. My arm is so stiff from writing today. Mr. Mac has done a lot of videos. I probably did 10 videos today. You can hear it in my voice. 3m plus m squared times 2 plus 4m times 3m plus 4m times 2 plus 6 times 3m plus 6 times 2. 3m to the third plus 2m squared plus 12m squared plus 8m plus 18m plus 12. 3m to the third plus 14m squared plus 26m plus 12. Z to the fourth times z squared plus z to the fourth times 3 plus 2z squared. We skipped one, so don't know if you saw that. 2z squared times z squared plus 2z squared times 3 minus 1 times z squared minus 1 times 3. So z to the 6th, remember, when we multiply like bases, we are going to add their exponents, plus 3z to the 4th plus 2z to the 4th plus 6z squared minus z squared minus 3, z to the 6th plus 5z to the 4th plus 5z squared minus 3. That was an interesting one. All right, now this isn't in standard form, so, and nor is this, so we most likely will have to rewrite our final answer in standard form. 2 times 3 plus 2 times negative y squared plus 2 times negative y to the 4th minus y squared times 3 minus y squared times negative y squared minus y squared times negative 4y. 6 minus 2y squared minus 2y to the 4th minus 3y squared plus y to the 4th plus y to the 6th. Let's just combine them first. Minus 5y squared. Let's combine them. Minus y to the 4th plus y to the 6th. Now we would write it in standard form. Y to the 6th minus y to the 4th minus 5y squared plus 6 is going to be my final answer. Your answer must be in standard form. All right, here are special cases. Special cases, these are called binomial squares. These are called conjugates. Binomial squares, there's a problem with that. You have x plus 2 quantity squared. Remember how I said you could distribute exponents? You can into multiplication. This is addition. You cannot, no, you cannot distribute exponents into addition or subtraction. That's a no-no. That does not equal x squared plus 4. Does not, underlined, equal x squared plus 4. That's so wrong. This, the base, this is the exponent, and this is the base. So we have 2 of these. So if you're going to do that, you need to understand that you're going to get x plus 2, x plus 2. We have 2 of the bases. And then you distribute plus, well, x times x. We won't do that. X times x plus x times 2 plus 2 times x plus 2 times 2. X squared plus 2x plus 2x plus 4. X squared plus 4x plus 4. Now, multiplying binomial squares have a template, and conjugates also have a template. So depending what your A and B is, your A, your first is always going to be your A squared. Your B, sorry, don't want that. Your B is always going to be B squared. And then your middle term is going to be 2 of your A times B. And this sign always goes here. And this is always, your second sign is always going to be positive. So when we have this, negative is always going to go there. So whatever your sign of your binomial is always going to go as your first sign. And this sign is always going to be positive because we're multiplying the same thing. Even when it's 2 negatives make a positive. And then when we have conjugates, the reason being is your inside and your outside are going to be opposite of each other, AB and negative AB. So they cancel, hence why you end up with only 2 terms. And negative because you have negative B times B, which is negative B squared. So that's really important. for you to see that, recognize it. Binomial square, we can put it in this template, a squared plus 2ab plus b squared, where this is our a and this is our b. So you have y squared plus 2 times y times 6 plus 6 squared. Y squared plus 12y plus 36. As easy as that. That's how you get binomial squares. You can write it as t minus 1, t minus 1. You can do t times t plus t times negative 1 minus 1 times t minus 1 times negative 1. T squared minus t plus 1. T squared minus 2t plus 1. It just takes longer. You should be able, in this day and age, remember the template. It's going to be minus 2ab because that is a negative. That's always going to be that sign. B squared, where this is my a and this is my b. So I have 2a, which is my a squared, minus 2 times my a times my b plus my b squared. Super easy, 4a squared, which gives me positive 12a plus 9. That's how most teachers are going to teach it. This is my a, this is my b. I'm subtracting. So the template I'm going to use is a squared minus 2ab plus b squared. 4z quantity squared minus 2 times my a times my b plus my b squared. 16z squared plus. That's going to be 40z plus 25. This is my a, this is my b. A squared plus 2ab plus b squared. X squared plus 2 times x times 2y plus the quantity 2y squared. X squared plus 4xy plus 4y squared. That's fast. That's fast, that's efficient. Now we're dealing with conjugates. We notice our outside is negative 9m and my inside is positive 9m. And what happens with those? They just cancel. Remember, it's first, outer, inner, and then last. So we're just left with, the template is first squared minus last squared. So my first, this is my first, this is my last. So it's m squared minus 9 squared, m squared minus 81. Real easy. My inside and outside cancels. So this is my firsts, 4k quantity squared minus my lasts, 5 squared, 16k squared minus 25. We always know it's going to be, and this is how we come up with the difference of squares. There are characteristics about conjugates, two terms, subtraction, both perfect squares. That's really it. 8 squared minus p squared, 64 minus p squared. Now you'll see some books write it like that, some books write it like that. It's kind of hard. Maybe even some books write it like that. I'm probably going to write it like that. I like standard form. Conjugates, so quantity 2x squared minus y squared, 4x squared minus y squared. These should be that easy. So we're going to multiply those two first, and then we'll distribute that in. So we have k, and we have k squared plus 2k minus 3k minus 6. I just did that distribution really fast. K squared minus k minus 6. Now let's distribute that last product in. It's easier that way to weight k to the third minus k squared minus 6k. I'm going to wait. You could go left to right. You could multiply these, make that g squared plus 6g times g minus 6, and then distribute those. 6 of one, half dozen the other. You get g to the third minus 6g squared plus 6g squared minus 36g, and that's a wacky one. And the reason being is you have conjugates, so you would have ended up with a 2-term. So if you had done it the other way, you would have gotten g squared minus 36, and then you get g to the third minus 36g. Much easier. Yeah. Here I am showing you. These are still conjugates. X to the third squared minus 7 squared. Power of a power is 3 times 2, so x to the 6th minus 49. Recognizing, oh, okay, this is an interesting one. Good. So x squared times x plus x squared times negative y plus xy times x plus xy times negative y plus y squared times x plus y squared times negative y. All I did was distribute, distribute, and distribute each of the terms into the binomial. X to the third minus x squared y plus x squared y minus xy squared plus xy squared minus y cubed. These cancel, x cubed minus y cubed. That is going to be a special template going backwards. When you get the difference of cubes, it'll produce that template above that you started with. A little FYI, a little flash forward for you. Plus 5r squared times 3 plus 1 times 2r squared plus 1 times 3, 10r to the fourth, plus 15r squared plus 2r squared plus 3, 10r to the fourth plus 17r squared plus 3. Almost done here. Ooh, that's tricky. Did you recognize that we have an exponent that we have to solve first? So we have m squared, and now we have a binomial squared. So that's m squared minus 2 times m times b plus b squared. So it's m squared times m squared minus, plus 8m plus 16. And now distribute. M to the fourth plus 8m to the third plus 16m squared. All I did was distribute m squared times n squared, m to the fourth, m squared times 8m, 8m to the third, m squared times 16, 16m squared. Those are conjugates. So that's going to give us 4y squared minus 81. Can you do it that fast? That's what you should be shooting for. 4y to the fourth minus 81y squared. That takes 10 seconds. On any assessment, SAT, PSAT, placement test, you should be doing that problem that fast. These are not conjugates, so we'll still multiply those. That's 2s squared minus st minus 2st plus t squared. St times 2s squared minus 3st plus t squared. Let's distribute the st in. So 2s to the third t minus 3s squared t squared plus st to the third. No like terms. It is in descending order. First variable, we have s to the third, s to the second, s to the first. So it is in standard form. Let's square this first. That's a binomial square. So we get c squared plus 2 times a, times a times b plus b squared. and that's outside the CD. So CD times C squared plus 4CD plus 4D squared. Now distribute the CD into there. C to the third D plus 4C squared D squared plus 4CD to the third. And we're done. I think I did 10 videos today. That's good though. You all need to practice it, so I'm taking the time to put it up there so you can prepare it, so you can take advantage. No excuses. Put in the extra work. Lots of capabilities, but who has the willingness to do it? Are you willing to do the extra work? Good luck.